Day one of my ML journey. Today I make a regression model using linear regression and comparing it with Ridge Regression with the library scikit-learn from Python using one of its built-in datasets, which is the California housing data. In this video, I'll walk you through the steps, the code, and the visualizations or plots. As you can see here, I have some markdown already printed, which is a title, the project, and my name. And let's go cell by cell. Here I import the necessary libraries for dependencies. 90% of them are from scikit-learn. In this case, we're importing data sets. In this case, we're getting the data, the California housing. From model selection, we're getting the train test split to train and test our data sets. Also pipeline, we're using pre-processing using standard scalar. And for the linear model, we're gonna use or import two, which is linear regression and ridge. And from the visualizations, we're gonna do quintessential matplotlib pyplot as PLT and numpy as MP. As you see here, I don't have pandas as PD. I left it by accident, so I'm gonna import it later in the code, almost at the end, as you will see. That's okay, mistakes do happen. Let's continue with this mini project. First, we're gonna load this data set as a pandas data frame. As I just saw a typo there, and we're gonna use housing equals fetch California housing as frame equals true. We're gonna assign two variables, the x and y, as the data and the target. We're gonna print the shape of each, and because my Windows is on dark mode, I assume it's printing the code like this, or the output, and we have 8 columns with more than 20,000 rows, and these are a preview of them using the head command. In this case, the median income has different values here from 8 through 3. The house age is from 41 years to 52 years, at least in the first 5 rows. The average rooms, average bedrooms, population, occupation, latitude, and longitude. What we do here, we're gonna create these variables, the train test, the X test, the Y train, and the Y test, and we're gonna split it on an 80-20 ratio. In this case, we're gonna use 0.2, and the random state, just to keep it standard, we're gonna use it as 42 for replication. Then we created a pipeline with the scaling and model. In this case, we're using standard scalar and linear regression, and we're feeding the model into the pipeline with the train and X train and Y train. And here is the output. And we're gonna run the first 5 predictions using the widespread variable that we have. And we're gonna predict it based on the X test variable, and here we can see we're using the first 5, and the outputs and numpy array of 5 values, and here they are. Now we're gonna do a model evaluation of the mean absolute error and the root mean square error. Here we type the code that we have here, basically comparing the Y test with the widespread. And the same goes with the mean square error, Y test and widespread. And you have the printed output, which in this case is 0.5332 for the MAE, and for the RMSE we have about 0.7455. And then we're gonna plot the results using matplotlib. So here we're using plot as figure at 8:6. We're using an alpha level of 0.5, so the color is a little bit half of the intensity value, and we're adding some labels, the X label, the Y label, the actual values versus the predicted values. And we are obviously adding the title, in this case the California housing regression, and here we're adding that reference line as well using this R command with the dash dash, and then we're showing the predicted values. And here we have, they're pretty spot on, one against the other. We're missing the legend here. We're gonna add it on a subsequent visualization down below. And for the Ridge regression, again, similar process. We're gonna do a pipeline, and we're gonna use standard scalar and the alpha level of 1 for the regularization strength. And we're feeding that model into the pipeline on the Ridge pipeline. Similar concept here. We're predicting the X test here with the first 5 rows, and we have almost similar results as the one we have here above, on top, I mean. Right here, they're very similar. Here we brought pandas as PD using standard naming conventions, and result bringing a data frame, a small table here, creating the titles here, linear regression with ridge regression, the initials here of mean absolute value and root mean square error. Here we have the errors are very similar. We do see, however, with the ridge regression, with the ridge regression, we see that the root mean square error, it's slightly lower, which is always good. You always want to keep your RMSE and MAE as low as you can. And here we actually adding some enhancements to our originally plot code that we had on the top. So here we added both scatter plots, and we're using the labels here that appear here with the legend argument. This will pop up. Now we're adding the title. We change it a little bit because we're comparing both regressions. We're using a tight layout, and we are also saving the figure here on my GitHub using a DPI of 150. And here we are. And here I added some enhancements for my portfolio. Keep in mind, this is my first attempt, so I got ideas from the internet and AI on how to make this happen. So I have here tabulate, and I installed it within this notebook. And in essence, what this code is doing is printing the results into a small markdown file, and this is the output. Just looks more nice. And then that particular file, I saved it within my root folder here, ML journey, and basically I added the title, the type of encoding, and basically added the format, and here is where it's saved. And with that wraps up my first mini project using Python. It took about an hour and a half to get back into the groove. It's been a while since I've been without coding after my master's program, at least with Python. So I'm very happy that I got the opportunity to get back to this, and I hope you like it. Stay tuned for more. Take care.